Hello and welcome to the Architecture Decisions segment of this video. In this segment, we'll be looking at what an architecture decision is, how to justify your decisions, and finally, how to effectively communicate and document those decisions. So I guess the best place to start is to ask, what is an architecture decision? I suppose we can say it's a decision that impacts or affects the overall architecture of the system, but that's not really an answer. That's really restating the question. So this is a very hard question to answer in any sort of concise term or something like this. So what we're going to do is kind of look at various aspects of architecture decisions to kind of frame and help guide you in terms of what is and isn't an architecture decision. So if we look at this graph right here, we'll notice that this graphs the type of change based on the level of difficulty, and we kind of see the change being either an implementation kind of change, a design change, or an architecture change, and the level of difficulty, easy, moderate, hard, or very hard. And we can kind of see as we start looking at the curve, once we get to design, the change of the level of difficulty gets moderate. As we hit architecture, it starts to get hard to very hard. And this is the area in which we can identify an architecture change. So I guess you can kind of say, basically, that an architecture change, or at least I should say one definition we can say, is that an architecture change is the type of change that's very, very hard to implement or that has broad reach within the application. Okay, we saw in the first Software Architecture Fundamentals video that an architect is responsible for defining the architecture and design principles used to guide the technology decisions. Now, in many cases, it really is the architect who actually makes those technology decisions. But really what we're focusing on the word here in terms of an expectation or responsibility really is to guide those technology decisions. And this is a much more difficult task than actually making the decision itself. So the trick right here is to focus on the overall impact the decision has on the system and the level of difficulty in implementing that decision. So, for example, suppose that the decision to use a Java Server Faces, or JSF, as your web framework. Is this an architecture decision? A lot of times you may say yes. Some people may say no because it's a technical one. But it is hard. Well, one of the things, and this is, I'm pointing out the gray area of architecture decisions. So while you may argue, yes, this is definitely an architecture decision, one technique is to try to broaden the scope of that decision. For example, here we might say the decision to use a web-based user interface for your application is definitely an architecture decision. And you can see it essentially guides the technology decision to use JSF. So it really puts into question the first statement up there, which is the decision to use JSF as your web framework. Let's look at another example which is typically deemed an architecture decision. How about the decision to use REST to communicate between distributed components? Architecture decision or more of a design or technical decision? Again, one technique is to broaden the scope and say, well, the decision that components should be distributed remotely for better scalability is definitely an architecture decision, which tends to guide the technical choice of using REST. So you can kind of see in terms of framing an architecture decision, does the decision guide a technology choice? If it does, then chances are that's a good criteria to say that that's an architecture decision. But it doesn't necessarily negate the prior two examples of using REST or JSF. In other words, it doesn't negate that those aren't architecture decisions, but that the other ones definitely are. So now that I've probably completely confused you, let's look at some other types of criteria to choose whether a decision is an architecture one. So one question you could ask yourself if trying to decide whether this is really an architecture decision or more of a design or technical one is, does the impact of that decision, what sort of impact does that have on the overall system? And what is the level of difficulty in implementing that decision if we have to undergo a refactoring effort? Second question you can ask is, does that decision help guide the team in making technology choices, or does it make the technology choice for them? Okay, so let's run through an exercise, and I would like you to try to figure out whether this is an architecture decision or not. So you'll make the decision to use Xstream, or the Xstream library, to persist objects as XML. Question for you. Is this an architecture decision or not? So immediately, this is kind of a simple case where we can say, well, certainly not. That just has to do with technology. But it's better to go through kind of their criteria questions. For example, what is the overall impact on the system of this decision? Well, it's pretty minor. As a matter of fact, it's limited in scope to just those areas of the application that happen to need to persist objects as XML. Then ask, what is the level of difficulty to implement this decision, which is pretty easy. I mean, we just import the jar file and use the XStream library. So this is really easy decision. And is it technology? Yes. And if we take a look at that graph, we can see it's in the implementation easy quadrant. And certainly this is not an architecture decision. So let's look at another one. How about this? You make the decision to restrict access to the database to only those components in the business layer, not any other layer, including the presentation layer. Architecture decision? Well, seems clearly that it is, but let's run through those criteria just to really qualify it. What is the overall impact of this decision on the system? And it is broad-reaching. In other words, it impacts many, many components across a major layer. So yes, this has broad impact. The level of difficulty to implement this, especially as a refactoring effort, is fairly hard. And is this technology decision? Is there any sort of technology basis in here? And there's really not. This is all about refactoring and the organization of the components within the architecture. So clearly, again, using this criteria, this is definitely an architecture decision. Okay, let's go through another one. So far, this seems pretty easy, doesn't it? So how about this one? You make the decision to use Hibernate as the persistence framework for your application. Is this an architecture decision or not? So hopefully you've formed your own answer to that as the viewer, but let's go through the exercise and say, well, let's go through the criteria. What's the overall impact on the system or the application of this decision? And again, this is pretty broad-reaching. This is going to impact a lot of components, or including an entire layer of the architecture. So it is broad. What's the level of difficulty in implementing this, especially as a change or refactoring effort? Pretty large, because we're going to have to pull out whatever we currently are using as our persistence and put this in. Okay. Finally, though, is this a technology decision? And the answer to that is yes. So the question becomes, we've gone through our criteria, is this an architecture decision? What would you say? Well, if we look at the graph that we looked at in the very start of this segment, we notice that we tried to categorize architecture decisions as those things that are hard or very hard in a level of difficulty to implement. And I would say that this does fall into that category. So although this deals with technology, this could easily be classified as an architecture decision depending on the context of your particular situation or application. So now we can start to see the gray area of this even with the criteria. Let's go over one more, however. You make the decision to restrict database access to only the application owner of that database. In other words, what we're talking about here are application silos. Let's say we have 3 applications, A, B, and C, and each have their own database. If application C needs information from application A, it just can't connect to its database and grab that information. It actually has to ask application A for that information. And so that's really what this design decision is dictating. Is this an architecture change? Let's run through our criteria. What's the overall impact of this decision? Well, this is pretty broad-reaching because this doesn't only impact our application, but we can kind of see in the progression here getting to this part that this really has overarching impact across a wide variety of applications. And the level of difficulty to implement is very hard because in this case we're going to have to be making remote calls to applications. We're going to have to stand up remote services. We're going to have to deal with performance and contract. Yes, this is extremely hard. And is this a technology decision? No, of course not. This really has to do with components and their responsibilities and access allowances. So in fact, this is an architecture decision, but you can kind of see the impact. The second one we talked about restricting layers to persistence, was limited to applications. This is more of a system-wide type of architecture decision. So hopefully this has given you, just in these 4 exercises, an appreciation for really what is an architecture decision and what really isn't. So the next step in the process, once we've kind of formed an architecture decision, is really justifying those architecture decisions. So every architecture decision that you make really should be able to be justified. So this here is a groundhog. And most of your architecture decisions will lead to this. Actually, what they'll lead to is something called the Groundhog Day architecture anti-pattern. Now, the Groundhog Day anti-pattern really describes a situation where no one understands why a decision was made. So it keeps getting made and discussed over and over and over and over. It kind of gets its name from the movie Groundhog Day with Bill Murray, where it was Groundhog's Day every single solitary day, and it was kind of that infinite loop. So that's why it's extremely vital to make sure you justify all of your architecture decisions. So what I'd like to do now is go through a scenario and exercise to show you the process for justifying those decisions and kind of how you would form that architecture decision coupled with the justification. So here's the scenario. Let's assume we have a situation where we've got distributed applications and we've got some sort of internal client application that talks to an integration hub. In this case, I'm going to use the example of Mule, which then goes through ActiveMQ, some sort of message broker, in this case again ActiveMQ, which finally gets to an internal application to process that functionality and maybe return a result. Okay, so this is our current kind of application or system architecture here. So what the requirement is that we need to do what's called federating this Mule hub. In other words, right now it's serving internal clients. What we need to do is have a separate instance to service external clients and then another instance to service B2B clients. Okay, so we have an architecture decision to make with this particular requirement. Do we first use dedicated broker instances? In other words, do we have ActiveMQ tightly coupled with each Mule instance so that the application goes through a particular broker to get to Mule? Or do we use a centralized broker where the internal application talks to one broker that services all the Mule endpoints that are JMS? So when making an architecture decision such as this, you need to consider all the possibilities and kind of apply those possibilities and create a case to justify one decision over the other. So let's do that. So what we're going to do here is put both of those decisions up here. So we have the top one, which is the dedicated ActiveMQ instances, and we have the bottom one, which is the centralized broker. So dedicated broker, centralized broker. Good. So let's put our conditions and constraints on here. So first, we notice that the broker, in this case ActiveMQ, is only used to access Mule. So it's only used for Mule endpoints. In other words, there's no JMS logic anywhere else in any application that needs to use ActiveMQ out of the context of Mule. So that's one of the first things we observe in our overall systems. The second one is that we observe that we have low transaction volumes and we expect low transaction volume growth in the future. Okay? The third condition that we see is that application logic can actually be shared between different types of client applications. So in this case, for example, we have an internal and external clients that both need customer data. And that is actually serviced by a single component inside the internal application. So we've got kind of this situation where we've got some sharing between components. Okay, so it's important to identify all of the conditions and constraints or your situation before entering into justifying this. So the second thing is we analyze each option. So we kind of say, well, I really like the top one, the dedicated instance. So let's make an assumption or a hypothesis that that one's going to be better. So let's do some considerations here. How about the broker usage and the purpose? So the purpose of this broker is to be tightly coupled to Mule and only service Mule or used outside of that. And we notice here that we have no cases right now for the use of ActiveMQ outside the context of Mule, which really does kind of point to justifying that first top dedicated instance topology. So we might lean towards that and make our decision. Well, first of all, that's kind of a weak decision because even if we did need an additional ActiveMQ instance, there's nothing in the top architecture that prevents us from creating a special purpose one. So this even further kind of justifies the top one. But if we left it at that, we're going to enter into Groundhog's Day anti-pattern because that's not a strong enough justification to choose this particular topology. So let's keep going. So how about the consideration of overall message throughput? So clearly the dedicated instance topology that you see at the top there is much better for overall message throughput than the bottom one, which appears to be somewhat of a bottleneck. However, generally, in general senses, if you were to kind of just say, what's the best practice for this? You would probably get something in Google that looked like the top topology. And mainly because this is a much superior topology for high throughput messages. But our situation is low message throughput and expected low volumes, even in the future. So this isn't a decent justification to still choose the top one. So we keep going. Let's talk about the internal application coupling for a minute. So if you look at the top topology, what do you notice on that? You notice that the internal application there would need 3 ActiveMQ connections. One for external, one for internal, and one for B2B requests, which means that the internal application actually has to have knowledge about where that particular request is coming from. If we look at the bottom topology, however, with the centralized broker instance, the internal application only has a single broker instance, which means it's largely agnostic in terms of where that request is coming from, which client that's coming from, and which broker instance that's actually coming from. So this actually has switched the tables over to the bottom topology. However, choosing the bottom topology brings up other questions. So if we were to stop right there, this also would lead to the Groundhog Day anti-pattern. Why? Because any architect worth their weight in salt is going to look at that bottom topology and say, oh my gosh, I cannot believe that decision was made. There is clearly a single point of failure and a performance bottleneck associated with this. So stopping right there is going to produce the Groundhog Day anti-pattern. So we keep going, and we look at the single point of failure and performance bottleneck. Let's talk about the single point of failure piece first. So clearly this topology looks like a single point of failure. However, this is fairly easily solved through out-of-the-box functionality, for example, with ActiveMQ or any sort of enterprise broker, to produce a cluster of a failover cluster or even a network of brokers. And so this really isn't a concern based on those. Regarding the performance bottleneck, certainly clustering is the usual response to performance bottleneck. But again, remember, we're expecting low transaction volumes. So in our case, that really isn't a concern. So clearly, based on all of these criteria, isn't it interesting how we bounced from the top one down to the bottom one? And once we selected the bottom one, which is the centralized broker, we had to further justify other aspects of it. So we do the due diligence and come up with an architecture decision. And that architecture decision looks like this. Our decision is to use a centralized broker. Now, if we stopped right there, this is going to be brought up and discussed over and over and over. So you have to add and couple a justification statement in conjunction with your architecture decision. And I cannot stress enough how vital this piece is. So looking at this particular slide here, you can clearly see the justification statement here. For example, internal applications should not have to know from which broker instance the request came from. It should be agnostic, and that's just in the spirit of just decoupled components. Only one single broker connection is needed. And what is the good thing about this? Well, if we look at this slide, we can kind of see that something we didn't consider before, but this allows for the expansion of additional hub instances without changing the application. So if we took that external hub, for example, and we split that into 2 pieces, let's say due to some sort of security kind of requirement, we have no changes at all to the application. As a matter of fact, the application doesn't even know that's happening. And that's a proper type of architecture versus a more tightly coupled one, where if we did split that external broker instance into 2, that means that the application is now going to need to connect to an additional ActiveMQ instance, therefore having overreaching application changes. Also, in the justification statement, here we've said, due to the low request volumes, performance bottleneck is not an issue, and we could have even added here, besides, if we did start having it, we can always cluster this. And single point of failure is either addressed through clusterings, load balancing, or failover nodes. Okay. So this kind of leads to the last section in this video segment, which is documenting and communicating those architecture decisions. So, does this look familiar? Yes, it's email. And if your architecture decisions are going into this, that's what's called EDA. Now, EDA is a term in architecture that usually means event-driven architecture, but in this context it means email-driven architecture. And too many times, critical architecture decisions are emailed to people, resulting in lost files and forgotten decisions. Okay. So the key point here is that Outlook is not a document management tool, and as a matter of fact, is not the right place for your architecture decisions or documents. So you can even notice on the unread email up there in the red circle that there's 21,000 unread emails there, and unfortunately your latest architecture decision is in one of those 21,000, so it will probably never get read. So email-driven architecture is where people forget, lose, or don't even know that an architecture decision was made, and therefore don't implement the architecture as you originally had planned. Consider this. Somebody new joins the team. All of your decisions are in email. They don't have them. They don't have those old emails. And the usual response to this is, oh, I'll be sure and forward you all those emails. Well, hopefully if I can find all of them, because email gets archived, it gets deleted. Some folks don't even read the emails, and so this is just not the appropriate way to document or communicate architecture decisions. So what is? Let's talk first about documenting your architecture decisions. So there's two key points here. The first key point is to make sure you document all of your architecture decisions, preferably in a wiki, but if not in a wiki, then a central document rather than have multiple files, each representing one architecture decision, randomly spread throughout each project file or a crowded shared drive. Alternatively, you could partition, and something that I typically do is to partition my architecture decisions by category. So if I am using a shared drive, if there's no wiki available, I might have a architecture decisions folder in which I will have a document for general architecture decisions, a folder for application-related architecture decisions, and one for example, integration architecture decisions. You know, your categories may be different. In a wiki, I might separate each wiki page by those kind of categories. The second part of this, though, is to establish early on where your decisions will be documented. Don't change that location, and make sure that every team member knows where to go to find those. Okay, so that's the first half. The second half is really communicating those architecture decisions. So placing them in a central repository or central document is one half of the equation. So for communicating those, I prefer a push versus a pull model. So avoid the assumption that just because I documented it, people will read it. That's a poor assumption in most shops. Generally, I like to do the push type of model. For example, for critical architecture decisions, I will make sure that the right stakeholders know about that decision. I could do that through email by a notification to say, hey, I made a really important decision, please see, and then provide the link or a link to the document. I might even go and call or even face-to-face meeting with an important stakeholder if that critical architecture decision impacts them. The second thing that I like to do is to hold periodic whiteboard sessions with key stakeholders, and only those key stakeholders, because then they can communicate your architecture decisions to others, as opposed to bringing 30 people into a room and saying, here's what we decided. If I bring 5 people in, make sure they know it, they can tell their teams, and then at least the architecture decision gets communicated and everybody knows where it's well documented. So this has been the architecture decisions segment of this video, and thanks for watching.